Professor Sheep here. Welcome to my video on gravity. Today I've got my beautiful cameraman out there filming for me, and I'm about to drop the stones. Unlike in my teaser video where my cameraman was dropping the stones and I was the cameraman. Anyways, so let's begin, shall we? All the explanations to all these drops will be at the end of the video, so don't worry. So, first drop test. Small stone versus tennis ball. And 3, 2, 1. Alright, for our next drop, we're doing large stone versus little stone. In 3, 2, 1. Alright, so in this drop test, we did this little stone and this tennis ball, and then that same cut we did this large stone and this even smaller stone. We did this to show you that the acceleration due to the force of gravity is independent to the mass of the object. So this stone has a much greater mass than this tennis ball. And so we're to show you that these two objects should hit at the same time. Now, this one as well. This rock is far lighter than this massive stone by a lot. I mean, this weighs less than the tennis. No, about the same as the tennis ball. But there's also, you could say, what about surface area? Now, when it comes to this big stone, eventually this little stone will hit the ground first. At like 2,000 feet though. But we were at probably 7 meters, 7 to 10 meters for you metric fans. It's about 20 feet. So surface area isn't going to come into play. So this just to show you that the mass of the object does not matter when it comes to the acceleration due to gravity. Basketball versus tennis ball drop test. 3, 2, 1. So another drop, we did this basketball and this tennis ball to show you that at this distance, that 20 feet, that surface area has no effect, because this basketball has a much larger surface area than this small little tennis ball. You could argue that this tennis ball has this fuzz, and the fuzz could add a lot of surface area. Yes, but only by, the width of a hair. This basketball, even if it was smooth, it would still have more, but it's not even smooth. It has bumps and ridges all along it. That's even more surface area. So if I were to drop this from 2,000 feet or several hundred meters, this basketball would hit long after this tennis ball. Alright, this is the elevator drop test. Golf ball and small stone inside a bag filled with water. And 3, 2, 1, one shot. Well, this is a mess. This is the aftermath of the elevator drop test with the small stone and not tennis ball, golf ball. We found the golf ball way over there. Surprise for the rest of this is a complete mess. It was worse earlier, but look, you can see splatters way out to here, and it hit there. Look where the splatter is. This is ridiculous. That's 10, 15 feet. That's redonk. for those of you that don't know, what we did is we filled this gallon bag full of water. And then we put this golf ball and this little stone in the bag. Now, the reason why I put the water in there is because when we put the golf ball and the little rock in there before, the tennis ball would weigh the bag down and we wouldn't get the result we wanted. What we want to see is if the tennis... So this is actually not my experiment. This is my cameraman's experiment he wanted to test. But what he wanted to see is if the golf ball and the little rock, when they were inside that bag, if they would float up or if they stay at the bottom of the bag. This is simulating like being on an elevator. Now, I'm not sure what happened, but as near as I can tell when I was at the top, they stayed at the bottom. So if you're in an elevator and the cable cuts and it falls, you will not be weightless inside the elevator. You will be stuck to the bottom. I could be wrong. So I'd have to check the footage, and maybe I'll tell you in the explanation of the basketball and the tennis ball, Newton's third law experiment. But this is just to show you that when on an elevator and the cable cuts, what happens? The water was just so that we didn't have to worry about the tennis ball and the rock weighing the bag down. Otherwise, we got some great carnage out of that video. Newton's third law drop test. Take 1 and 3, 2, 1. Newton's third law drop test. Take 2 and 3, 2, 1. Woo! This is the explanation for the Newton's third law drop test. So what we did is we dropped this basketball and this tennis ball. We dropped the tennis ball on top of the basketball. Now, the basketball has a greater mass than this tennis ball, and coincidentally does weigh more, but we're focused on the mass here. So when we drop the basketball, it hits the ground. We're doing Newton's third law of motion here. For each action, there's an equal and opposite reaction. But what we're really showing you here is energy transfer. This basketball hits the ground, transfers all of its energy, some is lost due to the ground and elasticity of the ball and some heat and light energy, but the rest, all that kinetic energy is transferred into this tennis ball. So the tennis ball flies up. We got to go 30 feet. I'm 5'11.9 inches, and it went 30 feet, 10 feet above this slide. It was ridiculous, or redonk. I had never seen. We did a rock yesterday, and it didn't go as high as the tennis ball. It got close, but not as high. I was completely shocked. I'm probably gonna show a lot of bloopers in the video, a lot of the tennis ball dropping and. That's a blooper. Ouch.
Did that actually hurt?
Yeah, it hurt. Well, there you have it, ladies and gentlemen, my video on gravity. Now, there's lots of cuts and lots of editing in this video. I'd like to thank my cameraman for getting hold of some nice video editing software. It's only a once in a while thing. I don't think we're gonna have to do it again. So, I'd like to thank you all for watching. Please like, comment, share, and subscribe. Don't forget to hit the blue bell icon so you know every single time I post. And good night. Whee!